This lesson looks at examples of molten ionic compounds and how they can be used in electrolysis. Before going any further, you'll need to know what electrolysis is, and you may wish to refer to our lesson, What Happens in Electrolysis. Ionic compounds are formed by the strong electrostatic bonds between positive and negative ions. The oppositely charged ions are locked into a rigid and regular structure, and since the ions are fixed in position and aren't free moving, an ionic solid cannot conduct electricity or undergo electrolysis. But one way of making it conduct is to heat it until it melts. In our examples here, the cations or positive ions are all metals, but it's worth noting that hydrogen can also be a cation in an ionic compound. Well, we're going to look at molten sodium chloride. The ions are a sodium cation and a chloride anion. Sodium ions will be attracted to the negative electrode, the cathode, where they combine with electrons to give sodium atoms. This is a reduction reaction. Each ion gains one electron and sodium metal is produced. At the anode or positive electrode, the chloride ions will each give up an electron and become a neutral chlorine atom. This is an oxidation reaction. The single chlorine atoms then pair up to form chlorine molecules and chlorine gas is produced. Overall, the electrolysis has split the molten sodium chloride into its elements, sodium and chlorine. And this is how sodium and chlorine are produced industrially. The electrodes themselves are usually made from an inert material such as carbon or graphite. This is to ensure that the electrodes aren't involved with the reaction. Another example of electrolysis is with lead bromide, which can actually be done in a laboratory. At room temperature it's a solid, and as we've seen with other ionic solids, it won't conduct as the ions cannot freely move. But when it is heated and melts, it becomes an electrolyte. When the electrodes are connected to a DC power source, the lead cations will be attracted to the negative cathode, where they will gain the electrons and become lead atoms. And in this case, each cation requires 2 electrons to neutralize the 2+ positive charge. At the anode or positive electrode, the bromide ions will each lose a single electron and become bromine atoms. And like the chlorine atoms, they will pair up to form bromine molecules. Now, if you were to do this in a laboratory, you'd see silvery lead forming on the cathode and a brown gas being given off at the anode. This is bromine. The lead bromide has been decomposed into lead and bromine by electrolysis. So remember, electrolysis will cause any molten ionic compound to decompose into its elements. And the process is actually quite useful and is used a lot in industrial processes. One such example is the industrial extraction of aluminium from aluminium oxide, and it's explained in more details in our lesson Aluminium Extraction using Electrolysis.